Alright, welcome to this tutorial. In this tutorial, I'm going to demonstrate the triangle law of addition of vectors. So, this tutorial is kind of supplementary lecture for the students with curiosity to know the approach which gives us the formula of the addition of vectors in the case of triangle law. So let's consider two vectors v1 and vector v2. If you remember from the previous tutorial, it was said that we can use triangle law of addition when two vectors are in series. In other words, the tip of the first vector coincides the tail of the second one. So the resultant vector R is a vector that connects the tail of the first vector to the tip of the second one. Now I'm going to demonstrate the formula which we saw in the previous tutorial. First of all, I'm going to name these points as A, B, and C. Here I extend the vector v1, which is the side AB, and a vertical dashed line from the point C to the extension that creates a right triangle. So I name this point, this vertex, as D. Now I have three triangles. The biggest one is the triangle ACD, which is composed of two smaller triangles ABC and the triangle BCD. From trigonometry and geometry, I can write the Pythagorean theorem for the biggest triangle where AC is the hypotenuse, power 2 is equal to CD power 2 plus AD power 2. AD is a side that can be divided into portions of AB and BD. So I substitute AB plus BD with AD in the initial expression. That will be AC power 2 is equal to CD power 2 plus AB plus BD inside bracket power 2. Now I'm going to expand the square bracket, which will be CD power 2 plus AB power 2 plus BD power 2 plus 2AB times BD. Also from the triangle BCD, I can write another Pythagorean theorem, which is BC power 2 is equal to BD power 2 plus CD power 2. So here I can substitute this new expression in the initial one and rewrite AC power 2 is equal to BC power 2 minus BD power 2 plus AB power 2 plus BD power 2 plus 2AB times BD. So minus BD power 2 can be simplified with BD power 2 because they have opposite signs and we can get rid of them, and the expression can be written as AB power 2 plus BC power 2 plus 2AB times BD. If you remember, it was said that the extension of vector v1, or let's say the extension of the side AB, which is BD, makes an angle like alpha with the side BD, which represents the vector v2. So in this scenario, from trigonometry, I can write the cosine of alpha, which is the adjacent side BD, over the hypotenuse, which is BC. So if I rewrite this expression, BD will be equal to BC times cosine of alpha. So now I can substitute BC times cosine alpha with BD in the previous expression. That will be AC power 2 is equal to AB power 2 plus BC power 2 plus 2AB times, instead of BD, I'm writing BC times cosine of alpha. Now here, I'm going to replace the sides with vectors. Instead of AC, I can write R power 2 is equal to, instead of AB, V1 power 2 plus, instead of BC, V2 power 2, and so on. 2 V1 times V2 times cosine of alpha, and finally the square roots of R will give us the magnitude of the resultant vector, which is V1 power 2 plus V2 power 2 plus 2 times V1 times V2 times the cosine of alpha. Now you see, from geometry and trigonometry, we obtain the formula of triangle law of addition for vectors.